Today's topic is 8085 microprocessor addressing modes. So before going to the addressing mode topic, we can see what are the operations can be performed, how we can give the instructions to the microprocessor. To perform any operations, we have to give the corresponding instructions to the microprocessor. So in each instruction, programmer has to specify three things. The first one is the operations to be performed. Example, that is opcode. Suppose example addition, subtraction, move, jump, like that you have to give the operations. Next one, address of the source of the data. So address, where we are getting the data, either from registers or input or memory, like that you have to give the operands. The last one is the address of destination of the result. So after performing the operation, we have to store the address to the particular location. So we have to specify the address of the destination of the result. So these are the things, three things we have to specify in the each instruction. Next, we will see the definition of the addressing modes. So every instruction of a program has to operate on a data. So different ways of accessing data is called the addressing modes. So the data can be stored in memory, register, or directly we can give by the input device. So the different ways of accessing data is called the addressing modes, or it can be represented as addressing mode is the way the microprocessor identifies the operands for the instruction. The operands, that is the input, which input we are getting. It may be register or memory or the input device. So this is called the addressing modes. So next, there are 5 types of addressing modes in 8085. So first one is immediate addressing mode, second direct addressing mode, third register addressing mode, fourth register indirect addressing mode, fifth one is implicit addressing mode. So let us see one by one the types of the addressing mode in detail. First one is the immediate addressing mode. So in this mode, the operand is specified within the instruction itself. So see here, the operand is nothing but input. The second input we are getting either from register or memory. So in immediate addressing mode, the operand is specified within the instruction. Direct value we have to give it. Example, first one, MVI B, 45H. So this I indicates the immediate addressing mode. So here we are giving the 45H data, 8-bit data directly in the instruction itself. So this operation is 45H move the data immediately to the register B. So this 45 data is directly moved to the B register. Next example, LXI H, 3050H. So load LXI, X is nothing but the register pair. Here we are mentioning as H, so it is an HL register pair. So load the HL register pair with the operand 3050H immediately. So this 3050 is the direct value of the operand. Here also I indicates the immediate addressing mode. Next, third one, ADI09H. So ADI, I is the immediate addressing mode. AD is nothing but addition operation. So add the data 09H with the accumulator. So always the addition operation, subtraction operation is performed with the accumulator register. It is an 8-bit register. Here we are specifying the 09 as the direct value as the operand. So addition operation can be performed with the accumulator and the 09 value. So this is the immediate addressing mode. So next we will move on to the direct addressing mode. So in direct addressing mode, the address of the data, that is operand, is specified in the instruction itself. So in the immediate, we are specifying the data in the instruction. In the direct addressing mode, we are specifying the address of the data. So examples, LDA. So LDA is nothing but load accumulator 2050. So the load the contents of the memory location into the accumulator A. The address is 2050. The value is present in the 2050 address. That value is directly loaded into the accumulator. Next example, LHLD 4500H. So 4500 is the address. The content of the 4500 is moved to the register pair, that is HL register pair. Next, store STA 2005. Store the contents of the accumulator into the memory location 2005. So here we are specifying the address of the data directly. That's why it is called the direct addressing mode. So next, register addressing mode. So in register addressing mode, the instruction specifies the name of the register in which data is available. The opcode specifies the address of the register in addition to the operation to be performed. So here we have to give the name of the 8-bit register. So example, move A, B. So B is one 8-bit register and then A is one another 8-bit register. The content of B register is moved to the A register. Next example, add B. So add B means B register content is added with the A register, that is accumulator. Finally, the result is stored in the A register. Next, INR A. INR A means increment A. So accumulator value, the content of A register is incremented by 1. So that is the, here we are mentioning the register instead of direct value or the direct address. That's why it is called the register addressing mode. Next, register indirect addressing mode. So in register indirect addressing mode, the instruction specifies the name of the register in which the address of the data is available. So move A, M. So M is nothing but indirectly it is mentioned as the HL register pair. So move the contents of the memory location pointed by the HL register pair to the accumulator. So indirectly it is mentioned as the HL register pair. That's why it is called the register indirect addressing mode. Next, sub M. So subtraction operations can be performed with the accumulator and the memory location, content of the memory location. So memory is nothing but the HL register pair. Next, DCRM. So DCR is nothing but decrement operation. So decrement the content of the memory location pointed by the HL register pair. The last one is the implicit addressing mode. So some instructions operate on the content of the accumulator. So such instructions do not require the address of the operand. Example, CMA. CMA is nothing but complement accumulator. So the content of the accumulator can be taken by the ones complement. Next, RRC. Rotate accumulator A right by 1 bit. This operations, all operations or the can be performed with the accumulator register. Then RLC. Rotate accumulator A left by 1 bit. So these operations does not need the operand or address of the operand. So the instructions can be operated by the content of the accumulator. This is called the implicit addressing modes. So these are the types of 5 addressing modes available in the 8085. So in the next class, we can see the instruction set of 8085.